Hello students. So today I am going to discuss some of the questions regarding a topic called as haloalkanes and haloarenes. So without wasting any time, we'll start with the first question. So the first question is, in SN2 substitution reaction of type, in a SN2 substitution reaction of a type, alkyl or aryl Br, that is haloalkane, plus chlorine in presence of DMF reacts to form RCl plus Br. Which one of the following has highest relative rate? Okay, so here the primary components will be always more reactive than secondary and tertiary. So for that reason, so here the primary component is CH3CH2Br, ethyl bromide. So the answer is B. In SN2 substitution reaction of the type, this reaction, which one of the following has highest relative rate? So primary are more reactive than secondary are more reactive than tertiary. So primary components are, as they are highly reactive because they are directly attached, so they have high relative rate. They will be having high relative rate. So the option is B. So second question, which of the following reaction is an example of nucleophilic substitution reaction? The electron rich negative charge components are called as nucleophile. So first Rx plus H2 gives rise to RH plus HX, halogen formation. Next 2Rx plus 2Na gives rise to alkyl groups with sodium halide. Then Rx plus KOH gives rise to alcoholic group plus KCl or KBr, halogen component. Rx plus Mg gives rise to RMgX, okay, which is called Grignard reagent. So which of the following reaction is the example of nucleophilic substitution reaction? Here, whatever the OH component that you are observing compared to sodium and hydrogen, this is not an option because of it is a Grignard reagent. So H2 and sodium are not electrophiles. Nucleophiles. Electron rich are called as nucleophile. So these are electrophiles. So the OH is the only thing which is a nucleophile. So the option for this, which of the following reaction is an example of nucleophilic substitution reaction, is C. Because OH is an nucleophile. Next question. Trichloroacetaldehyde Cl3CCl3CHO is the acetaldehyde reacts with chlorobenzene in presence of H2SO4. It produces, okay, trichloroacetaldehyde reacts with chlorobenzene. Now if you are going to write chlorobenzene C6H5Cl in presence of what? In presence of H2SO4. It leads to formation of what? I can make it as a 2. Okay? It leads to a formation of which component? Just try this reaction. Try to find out the answer for this. Yes, you try to find out the answer for this. Okay, so now how are you going to do this? So two benzyl groups are there. C6H5 gives rise to CH CCl3 plus C6H5. So this is the component what you are going to get in case of this reaction. So two benzyl groups, I can write the benzene structure also. Benzene, CH group, CCl3, again one more benzene ring. So the answer for this is B. Cl, benzene, CH, CCl3, Cl. So the answer for this is second one. So just we need to check the reaction, what is going to produce the product. Next question. This is question number 3. Let me go with question number 4. Question number 4. So, what is the question? Just I will rub this. So, what is the question? In a set of reaction, ethyl benzene yield a product benzene with CH2, single bond CH2 in presence of KMNO4 KOH. This is B product, Br2 FeBr, C C2H5OH, H plus. So what product we are going to get right here? Okay, just you take 2 minutes of time and you try this reaction by yourself, then I will solve. Okay, so now benzene reacts with KMNO4, which is a self-oxidizing agent, which undergo redox reaction. You can consider not self, which undergo redox reaction and it forms COOH group at ortho position. Then it's going to react with Br2. So as a result, COH group going to attach at this place, or even it can attach at this place. Okay, and Br you are going to get. Then again it's going to react with C2H5OH, ethyl alcohol. It's going to form a product called as A. COH C2H5 Br. So this is the answer for this reaction. So these are just to find out the reaction. Okay, so there is no much explanation will be there. So you need to just find out the reaction, how this reaction is taking place. Okay. Next question. Question number 5. The correct order of increasing reactivity of carbon halide bond towards nucleophile in the following compound is. So they have given the option like third, second, first, fourth, first, second, fourth, third, second, again second, first, fourth, third, first, second. Okay. So what order they going to form? In the formation of the correct order for increasing reactivity. So as you all know that if any component is directly attached to the benzene ring, it will be more reactive. So that is the more reactive compared to other components. So the first number is present at which option? It is present at this option B. So the answer is B. Okay. Then second reactive is ortho and para positions. And third one will be this position, and the fourth one will be this one. As the number of chain going to increase, the reactivity decreases. Here the number of chain is less, so it is more reactive than this one. So the option is B. Okay. Now next question. Okay. In the following reaction, in the following reaction, C6H5 CH2Br, where in presence of Mg or ether or H2O, a component is going to form called as X. The product is. So option A, C6H5 CH2O, CH2 C6H5. peroxide component, C6H5 CH2OH, C6H5 CH3, C6H5 CH2, CH2, C6H5. Yes, you try to think of this question and try the answer for this. What will be the answer for this question? You do try this. Okay, now we'll find out the answer for this. C6H5 CH2 is going to combine with Mg and going to form MgBr, magnesium bromide. Then again it's going to react with what? H2O. Okay, so as a result it's going to form what? C6H5 CH3. It's going to form. So the answer for this question will be C6H5 CH3. So answer is C. Answer is C. So already you have learned these reactions, just you are applying them. That is the thing. Which one is a nucleophilic substitution reaction among the following? Which one of the following is a nucleophilic substitution reaction? Option A, option B, option C, and option D. Which one is a nucleophilic substitution reaction? Yes, think of this. Yes, so the answer for this, which one of the following is nucleophilic substitution reaction? So what will be the answer for this? You try by yourself. Try this answer, try to find out. In this is HCN addition is a nucleophilic addition reaction. This is nucleophilic substitution reaction, and this is also a nucleophilic substitution nucleophilic addition reaction. This is nucleophilic substitution reaction. So out of B and D, the right answer for which one of the following is a nucleophilic substitution reaction among the following is. So based on the answer you can say D as well as B. D as well as B as the answer for this. Next. What products are formed when the following component is treated with Br2 in presence of FeBr3? So as you already know that whenever Br2 is made to react with any benzene ring, they are going to form what type of a product? Ortho and para products. So check where all you got ortho product and para products in an alternate way. So here CS3Br, no, not this one, because again here meta position is there. Here ortho and Br is there. Option A. Option B is ortho and para in opposite direction. These are present in the same direction. Same direction won't be possible here due to the presence of FeBr. So the answer for this is B. So answer for this is B. And C also. C. Meta position. This is ortho position. Here you can also find out. So Br is present, it can combine with hydrogen and it can form some other product. So due to the presence of bulkier group. So this is not an option. So only option is Br, this one. Here both sides you got a bulkier groups. Here you don't have a bulkier group. That's why B is the option. Next one. Ninth question. In which of the following compounds the carbon chloride bond ionization shall give most stable carbon ion? So this question you take it as a homework. So you try to solve this and let me know the answer for this. Next one. Which of the following reaction can be used for the preparation of alkyl halides? So you check this answer. You try to find out the answer for this. Take time and you try to find out the answer for this. So, in this CH3CH2OH, ethyl alcohol HCl in presence of anhydrous zinc chloride, it can form what? Alkyl halide. Whereas the same reaction is given right here, but there is the absence of what? A reagent called as zinc chloride. So this can't lead a alkyl halide in a normal way. Whereas these two reactions can lead a formation of alkyl halide in a normal way. So the option for this is 1, 3 and 4 can form a alkyl halides in a normal way, whereas second one does not form a alkyl halide in a normal way, but that is they require some reagents or catalyst. Okay, for that reason, so answer for this is A. A is the answer. Now, in an SN1 reaction on a chiral center, there is racemization, no, inversion, that is change in the configuration, retention, or getting back to the same position. Inversion and more than retention lead to a partial racemization. So both are forming. So the answer for this is inversion more than retention leading to the partial racemization. Now, which of the following can be used as a halide component for Friedrich-Crafts reaction? This is the first year reaction. Without doubt, we will go directly to the isopropyl chlorides. Next, consider the reaction CH3CH2CH2Br when going to react with NaCN. It going to form CH3CH2CH2CN plus NABr. This reaction will be faster in case of water, no polar solvents, methanol, non-polar, ethanol, non-polar. So the option is N-dimethyl formation. So in this N-dimethyl formamide, so reaction will be faster because these going to act like a positive catalyst which increases or decreases the, this is going to act as a positive catalyst which increases the rate of reaction, which makes the reaction faster. So these are the questions that I was supposed to discuss today. So one homework I have given already. Which question is that? This one, 9th question. You try to solve this question by yourself and let me know the answer for this. So these are the questions that I was supposed to discuss from haloalkanes to haloarenes. So remaining questions you can try yourself, and if you're going to get any doubts, you can ask directly. You can ask us directly. So I will stop right here. In next class, we will go with some other concepts and some other questions. Okay. Thank you.